Last episode, we made a lamp turn on with a button. I was so proud of myself. And then Haiz told me it doesn't actually work because if I hold the button, the lamp stays on, and if I let it go, it turns off. That's not a toggle. That's just me being a human switch. Today, we fixed that. But first, you need to understand what the PLC is actually doing behind the scenes. Because once you see it, everything clicks. Oh no, is this where my brain breaks? Only a little. Okay, so today we're answering 3 questions. First, why does my PLC see buttons presses differently than I do? Second, what is age detection and why do I suddenly care about it? And third, what the heck is an air trigger and why does every controls engineer love it? By the end of this video, you understand the single concept that separates beginner PLC programmers from competent ones. It's called the scan cycle, and once you get it, you debug logic faster, write cleaner code, and stop being surprised by weird PLC behavior. Let's go! Quick recap, last time we had this rung, 1 normally open contact for the button, 1 output coil for the lamp. Press the button, lamp on, release, lamp off. Easy. But I want a real toggle. Press once, lamp on, press again, lamp off. Like a light switch in your house, except it's a momentary push button. Here's where my brain went first. I thought, okay, I'll just add another contact. If the button is pressed and the lamp is off, it turns on. If the button is pressed and the lamp is on, turn it off. Simple, right? It sounds right, but it won't work. And to understand why, we need to look inside the PLC. A PLC doesn't work like your brain. Your brain is continuous. You see the button go down, you see it come back up. You process it in real time. A PLC is different. It works in cycles, discrete, repetitive cycles, and every cycle has 3 phases. Phase 1, read input. The PLC takes a snapshot of every input in the system, every button, every sensor, every signal. It stores those values in memory. That snapshot is frozen for the rest of the cycle. Phase 2, execute logic. The PLC runs your program, top to bottom, left to right, every rung, every instruction, using only the frozen snapshot from phase 1. It doesn't look at the real world during this phase, it looks at memory. Phase 3, update output. The PLC pushes the result to the physical world. Lamps turns on, valves open, motors start. Then it loops. Again, and again, and again. Typically every 5 to 50 milliseconds, depending on the PLC and the program size. That's hundreds of times per second. Now, here's the critical insight for today. If you press and hold the button for, let's say, half a second, that's 500 milliseconds. In that time, the PLC might complete 50 or 100 scan cycles. And in every single one of those cycles, the button is true. The PLC doesn't see 1 press. It sees 50 or 100 identical true signals. That's your problem. Oh, so when I press the button, even if I think I pressed it once, the PLC sees it as pressed 100 times? Exactly. And if your toggle logic fires on every scan where the button is true, it toggles on, off, on, off, on, off 100 times before you even lift your finger. The lamp would flicker at light speed and land on a random state. That's horrifying and kind of hilarious. Okay, so how do we fix this? We need the PLC to react to the button only once per press, not 100 times. We need to react to the moment that the signal changes, not the fact that the signal is true. Look at the timing diagram. The button signal goes from low to high. That transition right there, that's called a rising edge. Then it stays high for many scan cycles. Then it goes back to low. That's a falling edge. A normal contact in your rung evaluates true for the entire time the signal is high. That's the problem. What we want is an instruction that evaluates true for exactly one scan cycle. The moment the rising edge happens and then goes false again, even if the button is still being held. So it gives me one clean pulse, no matter how long I hold the button. One clean pulse, one scan cycle wide. That is edge detection. Meet rising trigger. The rising edge trigger function block. This little block is about to become your best friend. Our trig has two things you care about. An input called CLK, that's the signal you want to watch, and an output called Q. That's your one scan cycle pulse. You feed your button signal into CLK, and Q will give you the true for exactly one scan cycle every time the button goes from false to true. After that, Q goes back to false, even if the button is still being held down. Hold it for an hour, still just one pulse. I'm going to call the output PB pulse, because that's what it is. A clean, single scan pulse every time I press the button. Yep. And internally, how does AirTrig do this? It remembers the button state from the previous scan cycle. If last scan it was false, and this scan is true, rising edge detected. Q goes true for this scan cycle. Next scan, it says that last scan it was already true, so no edge. Q goes false. Simple, elegant, and it works because of the scan cycle we just talked about. So AirTrig is basically comparing the button now to the button one scan ago. Exactly. It needs memory of the past to detect change in the present. Remember that, because we're going to use that same concept again very soon. Let's build it. I've got my variables declared. Push button as bool for the physical input, PB pulse as bool for the AirTrig output, and lamp as bool for the output. Rung 1, AirTrig block, CLK input wired, a push button, Q output wired to PB pulse. Let's simulate. I'm forcing push button true and watch PB pulse. Did you see that? Blink and you missed it. PB pulse was true for exactly one scan cycle. Then false again. Then false again. Even though push button is still true right now. That is edge detection in action, baby. And notice, if I release push button and press it again, PB pulse fires again. One pulse per press. Clean, predictable, human proof. This is so satisfying. Let's zoom out. Edge detection isn't just about toggle switches. It's a fundamental technique in controls engineering. You use AirTrig and its sibling, FTrig, for falling edges, for counting events, parts on the conveyor, bottles on the line, triggering one-shot actions, start a timer, fire a solenoid, detecting alarm transitions, faults just appeared, not ongoing. Synchronizing sequences advance to next step on signal change. So basically, anytime I need the PLC to do something once when something changes, instead of continuously while it's true. That's the rule. If the question is, when did this happen? Use age detection. If the question is this true right now? Use a normal contact. 2 different questions, 2 different tools. Okay, so I have a clean pulse now. 1 press equals 1 pulse. Let's just hook it up to the lamp and call it a day. That's not right. No, it's not. Because now the lamp only stays on for 1 scan cycle, which is way too fast to see. You solved 1 problem and created another. A pulse isn't the same as a state. You need something to remember that the lamp should be on until you press the button again to turn it off. So I need the PLC to remember things now. Okay. You need memory, state, set, reset. And 1 more variable that's going to tie it all together. But that's episode 2B. So today you learned the PLC scan cycle, why holding a button confuses your logic, and how AirTrig gives you a clean 1 scan pulse. Next episode, we build the real toggle, memory, set, reset, and the final walking rung. Subscribe so you don't miss it. And in the comments, tell us, have you ever had a piece of equipment behave weirdly because of a scan cycle timing? Might get wants to hear the war stories. I really do. Bye-bye.